Today we want to take a look at the second day of probability, where we're using combinations and conditional probability. But let's go ahead and start with just a review of plain probability. Let's say that 2 die are rolled. Pictured below are all the possible cases. We want to find each probability. Now the nice thing about this picture is that it gives us all of our sums if we take a look at our rows and columns. So taking a look at all of my sums, if I want to roll a sum of 2, there's only one way to do that, a 1 and a 1. If I want to roll a sum of 3, notice I can roll a 2 and then a 1, or a 1 and then a 2. If I want to roll a sum of 4, I can roll a 3 and a 1, 2, 2, doubles, or a 1 and a 3. So you can see that the sums go diagonally up. I have all the possible ways I can roll a 5, or I can have all the ways I can roll a 6, 7s go straight up through the middle, a sum of 8, 9, 10, 11, or 12. And notice there is a little typo here. On my 11s, it should be a 6 and a 5, and then a 5 and a 6. So now that we have all of our different probabilities, let's take a look at, or our different possibilities, I should say. Let's take a look at finding the probability that I'm going to roll 2 die and get a sum of 6. So if I want the probability that my sum is 6, I know that there are a total of 36 rows here, or 36 rolls. And if I look at my diagonal for my 6s, I can roll a 5 and a 1, 4 and 2, 3, 3, 2, 4, or 1, 5. 1, 2, 3, 4, 5. There's 5 different ways that can happen. So that would be 5 out of 36. Maybe we have a review of an OR statement with overlap. So looking at number 2 here, we want to find the probability that my sum is greater than 8 or odd. So let's take a look at all the sums that are greater than 8. That would be the 9s, the 10s, the 11s, and the 12s. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those sums that are greater than 8 out of 36. Plus, half of my sums are odd and half of them are even, so that would be 18 out of 36. Now I have to subtract out the overlap, the ones that are both greater than 8 and odd. That would be the 9s and the 11s. So there are 1, 2, 3, 4 9s and 2 11s, which means I need to subtract out the 6 overlap out of the 36, which gives me 22 out of 36, which reduces down to 11/18. Maybe I have a not statement. So sometimes when I have a not statement, it's easier to find the probability of how to get it and subtract that from 1. So for question number 3, if I want the probability of not getting doubles, I'm going to take 1 minus the probability that I do get doubles. So I'm going to take 1 minus, I can get double 1s, double 2s, double 3s, double 4s, double 5s, or double 6s, which is 6 out of 36. So that would give me 30 out of 36, or 5/6. Maybe I'm rolling multiple times. So anytime I'm doing something multiple times, I want to multiply the probabilities. So for question number 4, I want to find the probability of rolling snake eyes, which is just a 1, 1, and snake eyes again. So on my first roll, there's only one way to do it. Snake eyes is when I get the double 1s. So that means that there is 1 out of 36 chances on my first roll. Well, when I roll again, that's going to be the same probability, 1 out of 36, which would give me 1 out of 1,296. So not very highly likely chances of rolling snake eyes twice. Now let's take a look at using combinations. When you're looking to get one particular group out of all the possible groups, you want to use combinations. The reason we're using a combination and not a permutation is that the order doesn't matter. Whether I pick a 2 first and then a 3 and then a 4 and then a 5, that's the same group as if I pick the 5 first, then the 4, then the 3, then the 2. I only want to count the group of the cards once. So that's why I want to use a combination, because order is not important. For question number 5, it says if you were playing poker and get dealt a 5-card hand, find the probability of getting all numbered cards. So if I want to think about what my numbered cards are, well, I know that there are 12 face cards, and I know that there are 4 aces. So that's 16. There are 52 cards in the deck. So if I take 52 minus 16, that means that there are 36 numbered cards. We've got the 2 through 10 of the hearts, the diamonds, the clubs, and the spades. So now that we know what we're looking for, we want to find the probability that we get all numbered cards. So let's start with the denominator. That's the easy part. I want to know how many ways can I get dealt a 5-card hand. If there's 52 cards in the deck, then that would be 52 choose 5. And that would give me all my possible different 5-card hands. I want to look for just the 5-card hands that are numbered. So now I'm just picking out of the 36 number cards. My numerator would be 36 choose 5. And if I take 36 choose 5 divided by 52 choose 5, that's going to get me about 0.145. So I'm running out of space. 0.145. So maybe a 14.5% chance of that happening. It's actually a pretty good chance. Number 6 says find the probability of getting dealt a hand of all red cards. So if I want the probability of getting all red cards, again, I'm going to start with the denominator. The denominator is always out of the total possible. So I want to know how many ways can I get a 5-card hand out of 52 cards. 52 choose 5. If I'm just looking at the red cards, there's 26 red cards and 26 black cards. So I want to know how many ways can I choose 5 out of the 26 red cards. And then if I do my division and plug it into my calculator, I'm going to get 0.0253. So only about a 2.5% chance of that happening. We could also take a look at our probabilities and our combinations with maybe groups of people. So let's look at number 7 on the back side next.